is a theory. It implies an extrapolation beyond the directly accessible information. Or it's from Fishbein in 1987. The second one, visualization is in moving graphics is an intuitive method for understanding relationships, and it is an excellent way to exhibit patterns. This is from Hans Rosling, and the three means it's also from Ola Rosling, and his daughter, she is called also Rosling. They did a visualization software called Gapminder. We'll see it later on, for real data. There has been an increasingly strong call for statistics education to focus more on statistical literacy, reasoning, and thinking. So this is Macker and Ben-Zvi, and they were talking about the role of context and in statistics education, including statistical literacy, statistical reasoning, and statistical thinking, and not only this calculation stuff. Then another one I like very much is Cher Thorpe in a TED Talk in Vancouver. He said, by placing data in human context, it gains meaning, and this is what we want to do with our students as well, so that's why I have it here. And the last one, higher education for sustainable development, aims at enabling people to not only acquire and generate knowledge, but also to reflect on further effects of the complexity of behavior and decisions in a future-oriented and global perspective of responsibility. So we have here also the context that we want to have in statistics education concerning the sustainable development. And now Melanie is explaining our model. We will change fast, quickly.
So the second theoretical background is on the left side. You can see the OXFAM Doughnut by Kate Raworth. She is a Scientologist, and she wants to combine some variables together in one model. It's called the OXFAM Doughnut because you can see the green circle. It's like a donut. And in the inside, you can see the social foundation. So, for example, energy, jobs, education, water. So, what we need that we have a good life. And outside, there is the environmental ceiling. For example, climate change, freshwater use, and so on. And this is what is bad for the environment. So it's good for a country when we fill the inside, so it's very full because we have a good education on some, and it's not very good when the outside is very full also. So we have to keep it small, that we are in the green circle. And there is also a good life. It's in the internet, a homepage where there are some donuts, for example, Austria and Costa Rica. We can see that Austria is very full in the inside, so the social foundation is very good in Austria. But on the other side, the environmental ceiling is very bad. For example, we can see the emissions and material footprint, ecological footprint, we are very high. So that is not so good. But we can see, for example, also Costa Rica. We can see it's close to a perfect donut. There are very good in the social variables, but not equality, okay, but yes, but they're very good, and they are not so high in the environmental ceiling than Austria. So they are the best country we found on this homepage.
So, and this is our idea. We made a graphic in, or applet in GeoGebra to visualize this model. And here you can see also the colors included. There you have inside the variables. Sometimes they are green, and if they are not so good, they are orange or red. And outside also, it's where it's good, it's green, and outside it's red. And the idea was that students can visually explore variables coming from the Gapminder software, and then they do their own Doughnut model for different countries. And yes, this was the idea in the project we did. So how they do it is we took the cycle of inquiry and visual analysis from Theodosia Podomu, where we are having a task and where we are foraging for data, searching for visual structure, developing insight, and then acting in our term it is to make the color red or green. We will skip that once, but we will show you some materials. So for the first time in a scientific context, we can present our board game here. We developed some weeks ago. It's called Doughnut Worry, and you can just throw a dice, and the students have to make some dots inside to understand, and they get score for it. And when they land in the green, they get 2 points. When they land on the yellow one, they get 1 point, and so on. And they get minus points when they are in the red one. And so they played the game in the lessons. They also had a worksheet for the Gapminder software, and they had the GeoGebra applet here, and I will just show you that one. That you know. Oh, yeah. Loading. So you can. Oh, you can't see. Okay. So maybe we'll skip that and make it in the break. Well, maybe here. Oh, okay. No? No, it's okay. Okay. So here you can see when you move these sliders, you can go up there, and you can also move the sliders for the outside here, and so students can do it themselves. They go to the Gapminder homepage, they look at the data, and they decide whether it's good or it's not so good. No? So we have also had a card game and so on, and maybe we have 1 minute left. Okay, 1 minute left. Maybe just the first insights. We did it in the schools, and we have some quotes from the students. I was astonished by the use or the number of mobile phones, the vaccination rate, and the number of endangered species. I've never thought of such results. Or surprisingly, our average monthly income is as high as the income in poor countries in an entire year. Or I have learned that people which live in the same country do not have the same income. This quote is, especially for me, it's very interesting because they, in Gapminder, they have just one average value, and we were not quite sure about if they take for inside the country, if they are aware of a distribution inside the country as well. And there we see, okay, they are aware that the countries also have different variables, different values. And there's a high pollution in our world because of CO2 emissions. Another problem in many countries is the energy use or the water withdrawal. So we see also that they develop some ESD competences. We have now a lot of data, maybe 30 or 50 gigabytes of videotapes and audio tapes and so on. And now we have maybe a half year of spotting the data and see what is coming out of the project. So, thank you very much for your attention, and maybe you have some questions.
So questions.
Sarah has a question.